The workshop today really the fundamental, very practical introduction to the main Prisma workflows. Who of you has actually worked with Prisma before? All right, a few people already. I'm not sure how much new things I'm going to teach you today then, because it's really for like complete newcomers, but you can ask questions and yeah, hopefully you're still able to take something away from the workshop. And the workshops that we have later in the day, I think these are going to be for you, because there we really have deep dives into certain workflows with Prisma and into actual application development with Prisma as well. Also, to get a feeling for the audience here and also for the people who are watching online, there is a like raise hand feature in the Zoom webinar here. And just by show of hand, I'm curious who I have in front of me. So are most of you JavaScript or TypeScript developers? If that's the case, then raise your hand. All right. Okay, almost everybody, almost everybody. Which programming language are you usually like using, if I can ask?
TypeScript as well, but mostly Go.
And Go, all right. All right, nice. All right, who would consider themselves here more of a front-end developer? All right, few people. Who would consider themselves exclusively backend, no front-end at all? All right, so I guess we have a lot of full-stack developers here. Mostly, okay, well, nice. Then let's get started and talk a little bit about the logistics of the workshop today. So here you can access the workshop document that is going to guide through the entire workshop and that I'm going to use to explain the tasks that you will be working on later. So you can already go ahead and go to that URL, pris.ly/day22intro, and then you'll open exactly this document that I'm also seeing right now. There also is a starter project that you can clone later. And as prerequisites for this workshop, you really only need to have Node.js, because that's what we're going to be working with. But you don't need to have a local database server running or anything, because we'll be using SQLite for this workshop. I would also recommend you to use Visual Studio Code for two reasons, because they have really great TypeScript support, and there is the Prisma VS Code extension that also works really well with VS Code. If you're used to another editor, or you want to use some other kind of IDE like WebStorm or something like this, that's also okay. There are community plugins actually also for WebStorm, but I've heard that people who are using WebStorm, that they actually just, when they have to make changes to the Prisma schema, they would open that inside of VS Code, make the edits there, and then go back to developing in WebStorm. Yeah. All right, you see, yeah. One question. Yes, of course. This is the link, pris.ly. I can also, sorry, it's a bit small. Yeah, it's our custom link shortener. What we'll cover in this workshop is that we'll start by setting up Prisma with a SQLite database. Then we learn about how to model data in Prisma and perform our first database migration. Then you learn about Prisma Client, which is Prisma's way to then actually read and write data in the database. So it's a type-safe query builder to send queries. And then depending on how much time we have, we can go to like lesson 3 or 4 or both, where you will then see how Prisma Client actually looks like in the context of a backend application that would either be a REST API with Express or a GraphQL API with Apollo Server. This is the rough agenda for today, like with the timing. So we're planning to have everything until 12. And then I think there is a plan for lunch, and then we'll follow with the next workshops today. This is an overview of the lessons. We'll dive into these when the time comes. But for now, I just want to give you a quick overview what a lesson looks like. So it's structured in 2 parts. In the first part, it's going to be me who is showing you what to do in the lesson, and I'll show you what the tasks look like and do a couple of them so that you already have an idea what you need to do. And you can use that time to really like pay attention and think about any questions that come to mind that I can then address. And in that phase, I would recommend you to not yet code along yourself. Of course, you can do that, but I think you'll get the most out of this workshop if you really use that time to pay attention, think of questions, and then afterwards, you get dedicated time to actually work on the tasks yourself. All right, who is teaching you this workshop today? So my name is Nikolas, and I've actually been with Prisma for 5.5 years now. So pretty much from the beginning, we were only 5 people when we started back then. We've moved offices twice since then. We started out in Mitte, like moved to another one in Torstraße, and now this is our 3rd office. But actually, since 2 years now, we've been entirely remote first. So this office is more like a co-working space now, where everybody can come in and go out as they please. And then a final note is that if you like this workshop today, and if you're excited about Prisma and you want to share this with friends or colleagues, then you can reuse all of the materials that I've prepared for this workshop. So this Notion document, you can just copy, you can edit it in any way you want. And you can also reuse my GitHub starter project. And if you have any questions about how to best teach a workshop, then I'm also always available and happy to chat with you. All right, any questions so far, or any questions in the chat? Oh, first question in the chat from Tanai. Okay, you can't see the questions in the chat, by the way. But like someone asked if it was possible to turn off the music. But I think the music is already off now, right? So maybe someone in the chat can confirm that. Music is off. All right, that's good to know. Yeah. That's a little bit weird about the setup where, okay, you can actually see the chat there. That's good. Because I have a couple of more like windows on my screen that you can't see that also sometimes block my vision. So if I move the cursor around sometimes and you don't know why, it's because I'm moving around the Zoom controls. All right. Any other questions so far? Everything clear, that's great. Then before we dive in, I actually quickly want to discuss with you what Prisma actually is and provide you with a high-level overview of like how it works and what the main components are. And instead of like walking through slides or anything, I actually just use our landing page to explain the main concepts here. But actually, I'm curious for you people here in the audience, the term that we see there, the next generation Node.js and TypeScript ORM. What does it stand for? These 3 letters ORM. Anybody knows that? Yeah. Object relational mapper. That's right. And why is it called that way? It's called that way because we work with two different data models, really. The one is the way how we model data in relational databases. And there the data is usually organized in tables. And if we want to build relationships across the data in our tables, then it means that we have to do that via foreign keys. And that's called the normalized way of structuring data, or also the flat way of structuring data. We don't really have any nested data anywhere. But then as JavaScript and TypeScript developers, we're really used to a different data model, because in JavaScript and TypeScript, we're working with objects, and these objects, they can be deeply nested. So on the top level, we can have an object that's called user, and then in there, we have a posts field, and that has an array where you have a number of posts that maybe each have a comment, and like we can work with these deeply nested objects in JavaScript. And usually, if you were to use a relational database and an object-oriented programming language, you have to perform that mapping yourself. That means you have to write SQL queries and then fumble with the results that you get back in order to get the data and the structure of like the actual nested objects that you want to work with. And that's why people use object relational mappers, because it's actually the like responsibility then of the ORM to perform exactly that mapping and make it easier for application developers to work with the data in the database without actually context switching so much between the mental model of flat and normalized data and object-oriented data that we're using in our programming language. Questions about that? Great. Who of you has worked with any kind of object relational mapper in the JavaScript or TypeScript ecosystem so far? Which ones have you used? Like maybe TypeORM or okay, TypeORM, Prisma, all right. All right, anybody has used SQLite? Okay, nice. What were maybe some like good points or bad points about your experience with SQLite?
Really lightweight.
Ah, okay, it's lightweight.
Focused on just doing that. Comes with another set of complications.
Nice. And like, would you say it was overall a good experience?
No.
No? So like, what were the bad parts?
Boilerplatey and like some unexpected things coming around, or like not being able to control.
Okay, so some unexpected behaviors and a lot of boilerplate. Interesting. All right, we call ourselves a next generation ORM. And the reason why we're calling ourselves that is because really Prisma works very or in a, like not in the same way as these like conventional ORMs, more traditional ones like TypeORM and SQLite, where you typically define your models as classes in your application code. These classes then map to tables. And when you instantiate them, you get these model instances on which you can then call like methods like save or insert or anything like this that would then actually like send queries to the database and read and write data there. With Prisma, we have a very different approach. So the first big difference is the way how you model your data. In Prisma, you don't do that using TypeScript or JavaScript, but we actually developed a specific like modeling language for that. That we call the Prisma schema language. And you see an example of that right there. We often get the initial reaction of people when they start like using Prisma, or actually before they start using Prisma, that they feel a little bit confused of why they need to learn another language just to use an ORM. If they already know JavaScript or TypeScript, like what's the benefit of that? And my usual reaction to that is that like I'm telling them to at least give it a try and see what it feels like to model data in the Prisma schema inside of VS Code. And usually the experience then is so delightful for these people that they actually turn around and become the biggest advocates of Prisma in the end and become a really big fan of that approach. So I really think that the way how you model the tables and the structures that you store inside your database with Prisma is really a big step forward compared to the traditional ways of doing that. And that you will all experience that throughout the workshop. Here is the languages and the databases that we support. And then here is the next component of Prisma, and that's Prisma Client. And that's the way how you then actually read and write data in the database. So the first step is you define your data model in the Prisma schema, and then you use Prisma Client to send queries to the database. And the interesting thing about Prisma Client actually is that it's auto-generated based on your schema. So the way how it works is that when you use Prisma and that you want to use Prisma Client, you first run a Prisma CLI command, Prisma generate, and then it reads the current Prisma schema and generates all the TypeScript types for you, and not only the types that correspond to your models, but also the entire data access API that you can then use with Prisma, including all the filters, pagination, and everything that you would expect from such an API that gives you an interface to a database. Then another component of Prisma that also most of the other ways or like libraries that you use for working with databases come with are migrations, and the tool in Prisma is called Prisma Migrate that enables that. And then we have Prisma Studio, which is a visual data browser. And you're going to get to know all of these tools in the workshop today. Again, any questions? Let me also check the chat. No new messages in the chat. That's great. Any questions in the room? Yes, one question.
I'm not sure if it makes sense to ask it here, but like maybe can you elaborate on the relationship between Prisma and TypeScript? Like, is it really you know, like it's the strict necessity to use TypeScript?
No, it's
type checking, for instance.
so it's completely optional. You can also use Prisma in a plain JavaScript application. But the cool thing is, and I think that's like pretty common also like these days with a lot of like NPM libraries, that we also provide you still, even if you're only using plain JavaScript, we still put the typings, the type definitions into your Node modules, which means you will still get the auto completion if you're using VS Code. And that's pretty cool. But of course, you don't get any real type checks. But even in even if you're only using JavaScript and you want to benefit a little bit of the type safety that's provided by Prisma Client, there is actually a way how you can also achieve that using JS doc, I think. In fact, we wrote a blog article about this a while ago. Here you go. Here is the like types, the type safe JavaScript, where you have like annotations in your code, I think in the form of just comments. And like these will be picked up, and then you also get a level of type safety, at least, even if you're using plain JavaScript. So like that often also is a nice compromise between the two. But no, you don't have to use TypeScript if you want to use Prisma. Questions in the chat. During the workshops, are you going to explain how exactly binaries are working? I mean, binary targets, which we're declaring inside schema.prisma. That's beyond the scope of the workshop today. If you have any specific questions about that that are not answered by our documentation, because I think there is pretty extensive docs about this already, then you can either ask this here in the chat as well, or I would encourage you to do what I would always encourage anyone who has a question about Prisma to do, to go to our main GitHub repo, click on the discussions tab here, and then ask your questions here. We have support engineers who are like monitoring the GitHub discussions most of the time. So you are likely to get an answer there either by us or our community. Second question, at this moment, it is not possible to tell Prisma the exact type of a JSON B field. As far as I know, there is a beta version of MongoDB. Not so much a question, but it might very well be that Prisma support for the beta features of MongoDB isn't like really there yet. So you probably have to work around this. All right. Then I think we can go back to the workshop document. Remember, this is the host walkthrough now of the first lesson, so I encourage you to pay attention, and then later you get time to work on this yourself. All right, so the goal of this lesson is to set up Prisma, get comfortable with Prisma's data modeling language, and perform your first database migration. And the way how you can do this is by cloning this project from GitHub. The instructions for that are also here in the README. I'm going to open up my my terminal here, increasing the font size maybe a bit, and now run the commands by just copying and pasting them from the GitHub README and then opening the new folder that I have in VS Code. There we go. So let's get a quick overview of what this project looks like at the moment. And let's do that by taking a quick peek at the package.json file here. So we see that we really only have 3 development dependencies. One is the Prisma CLI, and then 2 to make this work with TypeScript, and then 1 runtime dependency, and that's the one for Prisma Client. Then we have this very simple script TS file where we only have 1 function. And in this and the next lesson, we're only going to write Prisma Client queries inside of that function to just become a little bit more familiar with the Prisma Client API before we then start talking about what Prisma looks like in the context of an actual server-side application. But in this lesson, we're actually not going to use the script just yet because we only want to set up Prisma and are going to use Prisma Studio a bit later to store some data. Also quickly just want to show the TS config here that we've configured, and then this Prisma folder with the schema.prisma file that I think you all have been waiting for. So here is what a Prisma schema looks like. And the Prisma schema in general has three main components. Two of these components you already see here. One is the data source that specifies the connection to my database. And for this workshop today, we're using SQLite, as I already told you. It's just easier because you don't have to set up your local Postgres instance or local MySQL instance, and don't need to have any extra software. But if you wanted to use another provider here, another database, then you can just use the connector for the database that you would like to use. And here, by the way, you already see one of the cool features of the Prisma VS Code extension, and that's the auto completion. So like, whenever you don't really know what to type, when you're in the Prisma schema, you can hit Control Space in your editor, and then it'll bring up the smart suggestions here. And here we are telling Prisma that the SQLite database file that we want to use should just be called dev.db. The second component is this. That's the Prisma Client generator. You don't really have to understand what this means. You just need to know at the moment that you need this if you want to use Prisma Client. There are other kind of tools that you can use here, other generators that are built by our community that also take in the Prisma schema and spit out like something else. So like for example, we have one for like from the Prisma schema into DBML, which is another standard way of like modeling data that can be then directly visually represented as an entity relationship diagram. So it's basically a way to quickly visualize a Prisma schema and see what the corresponding database structure looks like. But here we are just using the generator for Prisma Client. All right, with that overview, we can go back to the Notion document and check out the first task. So here's just the explanation of the same things that I just described. And here is the description of the first task. So we should start by creating a user model with 3 fields, an auto-incrementing integer as an ID, a name that should be optional in the database, and an email that should be required and unique in the database. So how are we going about that? I'm going to show you first. I'm in the Prisma schema again, and I'm using Control Space to just see what kind of options I have here on the top level. And we already specified the data source and the generator. So the third component of the Prisma schema actually is the data model, which consists of 1 or more models. And here I'm using that model keyword and specifying the name for that new model. And we want to have an auto-incrementing integer as the ID. And the way how you can do this in Prisma is that you're using the @ID attribute, which indicates that this field is going to map to the primary key in the underlying database. And then you can also assign a default value to this field. And in this case, we don't assign a static one, but instead we're using this function, which is just an auto-incrementing integer in the underlying database. The second field was a name, and it's of type string here. Like that's the way how I want to model it. And it should be optional in the database. And if you are familiar with SQL, you know that when you define a new column in SQL, then by default it is nullable. And if you don't want it to be nullable, then you have to explicitly say that it's not null. Well, in Prisma, it's the other way around. So in Prisma, by default, all the fields that you define on your models will be required, will be not nullable. And if you want to make them nullable, if you want to make them optional, then you have to append the question mark right after the type as a type modifier. And then we also have the email field that should be a string. This time it should be required. So notice how I don't add the question mark here. And it also is supposed to be unique. So I'm adding the unique attribute here as well. And now I'm showing you another feature of the Prisma VS Code extension, and that's the formatting feature. So a lot of people have this mapped just to like saving the file. For me, I have an explicit shortcut for that. And if you invoke the formatting, then you get this nice column-based layout for field names, field types, and field attributes. These models, of course, I haven't made that explicit, but these models are then mapped to the table in the underlying database using Prisma Migrate. And that's exactly what we want to do in the next step. So I'm going back to the Notion document yeah, I'm looking at the second task here. And here, by the way, all the solutions for the tasks are also directly embedded in the Notion document. So if you want to compare your solution with the correct one, then you can always go and expand the solution block here. So now we want to run our first migration. For that, I'm linking to the docs for you to figure out the command. But I already know the command, so I don't have to go into the docs. I can just show you. The way how we use this Prisma Migrate command is using the Prisma CLI. One recommendation, again, as kind of a good practice for how to use the CLI when it's installed locally is to always prefix it with npx. And if you do that, it ensures that you're always using the local installation inside of your current NPM project. That's usually the safer way to always install these CLIs locally in your project and then prix them with npx, because then you're always sure that you're using the CLI version from that specific project. Sometimes if you have a global installation of the CLI, or if you have multiple projects, then it can get confusing with the versions. And to prevent that in the first place, it's just good practice to always prefix the CLI commands with npx, so you're on the safe side. If I just run npx Prisma, we'll just get the overview and synopsis of the Prisma CLI, like with a list of all the commands, and we see that there is a Prisma Migrate command. So if I run npx Prisma Migrate, let's see what's happening then. We now see that, again, it's actually a subcommand, and the real command we have to, again, append to Prisma Migrate. And in this case, we actually want to use the Prisma Migrate def command. So let's go ahead and do that, npx Prisma Migrate def. And I can provide a name for the migration. What this migration does anyway, it creates a new folder on the file system. And to give a name to that folder, I can provide a name here in the CLI command directly. So I'm running this command. We see a bit of output here. So we actually now have a database. Before, we just had this local Prisma schema file, but we didn't actually have a database. Now, after running this command, it seems like there was a new database created at this file path, and we will look at this in just a second. Also, it says applying migration here. Also gives me this file tree structure with a new top-level folder called migrations. Then with the folder name for the current migration, we recognize the init, the name that I gave this migration, and a timestamp right here to make this unique. And then inside there, we have a migration.sql file. So let's go and explore a little bit what has changed and what has happened on the file system. And indeed, we see that we have the SQLite database file called defdb. So that's as expected. The name that we provisioned in the Prisma schema was picked up here. And then we have this new migrations directory where inside we have this new folder with the name of the migration with the timestamp. And inside there, we have a SQL file that actually now represents the data model that I specified in the Prisma schema before. So that's the SQL that was actually executed against the database. And if at any point you want to have, or like you want to make use of a feature that's maybe not natively supported in the Prisma schema file, you can always go to just go and create this migration file first. And then before you apply it against the database, you can make edits right in here. So that's how you can still use all the functionalities that your actual database provides by just like go in and basically customizing this migration file here. All right, let's move on to the last task, and that is to just create three records inside of Prisma Studio. One quick side note again, here you also see that Prisma Client was already generated. So in the beginning, I mentioned that you have to run the Prisma generate command in order to get your Prisma Client. But when you're running Prisma migrate dev, this is running Prisma generate for you under the hood already so that you don't have to explicitly run it yourselves. So that's just convenience. All right, in order to use Prisma Studio, I'm running the npx Prisma Studio command, and this is now opening up Prisma Studio in a web browser for me. And it looks like this in the beginning, where you have the overview of all of your models. At the moment, I only have one model with 0 records. So if I click on that, then I see the table, and I can go ahead and create 3 records here. So I'm going ahead and creating 3 of these. Nilu is my colleague who is working on the docs. And then Alex is one of our developer advocates. Oh, I guess, oh, okay, I think I have to recreate Nilu. And save 3 changes, and we have stored 3 records in the database using Prisma Studio. That's it for the first lesson. You can now get to work yourself and get your hands dirty a little bit, and I will check the questions in the chat, and in 10 minutes probably we can continue, and that's when I will pick up the questions from the chat as well. Quick show of hands, who of you is done with all the 3 tasks? You can raise your hand, and also on Zoom, you can also raise your hand. Not everybody, so okay, yeah, looks good. Okay, so then let's move on. There have been a couple of questions anyway that I want to address first. So if you haven't been able to follow through with all the tasks yet, you can still do that, as I'm going to go through questions. So the first question was, would you need to run Prisma Generate with Prisma Migrate deploy? So with Prisma Migrate, we have different commands depending on which environment we're working in. And in a local environment, when you're developing, you're using Prisma Migrate dev. That's what we're going to use today. But when you deploy in production in a CI/CD environment, that's when you want to use Prisma Migrate deploy. And the question is whether that's also running Prisma Generate. And to be honest, I'm not 100% sure, but I believe so. If you want to be on the safe side, then usually you can still just run Prisma Generate. It's usually not like a big deal, but I'm actually not 100% sure about this. It does? It does. All right, thanks. Next question. What's the best practice when starting a new project from scratch? Working on the D and doing a DB pull to sync the schema, or the other way around, like I just showed? That's a really good question. And for you to be aware, there are 2 ways how you can work with the Prisma schema, basically. One is you define your database schema inside of the Prisma schema, you generate SQL migrations for it, and then you apply the SQL migrations against the database. So that's kind of the Prisma first approach, you could say. But you could also use a database first approach. If you say, okay, I actually don't want to use Prisma Migrate, I just want to use another migration tool or write my own SQL migrations, then you can do that. And then with another Prisma CLI command, you can run an introspection against the database that is reading the database schema and then turning that into a Prisma schema. So that's the other way around. That's also possible, would be maybe called database first. I would recommend, if you're using Prisma, then I don't see a reason why, especially when you're starting out a new project, why you wouldn't go with Prisma Migrate, because you still get all the flexibility to use like SQL features that are not representable in the Prisma schema with the approach that I showed you of customizing migrations. So I would probably recommend to go with Prisma Migrate unless you have a really good reason not to. If your company already has a proven migration system and you want to keep using that, that's totally fine. And in that case, you can use the other approach, of course. But I think starting out from scratch, Prisma Migrate is probably the way to go. Next question. Could you explain a recommended workflow when you're working on a feature and you're introducing many DB schema changes? What is the recommended way to do this? Should we create a migration for every change or use Prisma DB push until we reach a stable version and then generate the migration script? Again, we have people here that already know a little bit about Prisma. That's nice. So what this person is asking is when you're working in local development and you just have to iterate on the schema over and over, and you don't really care about keeping track of the history of all of these changes, that's when you can actually use another command that's called Prisma DB push. And that just takes your current Prisma schema and applies it against the database. And that's typically what's recommended if you're exactly in that kind of prototyping phase, you need to iterate fast and you don't care about tracking anything. That's when you can use Prisma DB push. And at some point when you feel, okay, now the schema has reached a state where I want to commit everything into my branch, then you can go ahead and generate the actual migration files for the current state of the database. So yes, I would recommend to go with Prisma DB push if you're in that position. Yeah.
That means that when we ran Prisma migrate and we provided the name, this would be for versioning.
Yes, exactly. Yes, exactly. It's to keep track of the migration history and to keep track of the changes that you're introducing to your database over time. And if you're sticking around for the next workshop by Alex, he's going to talk about exactly these migration workflows in a little bit more detail, and also will cover the Prisma DB push command. And Muhannad also already had the right intuition here in the chat and recommended Prisma DB push. Then there were just confusions about where the Notion document is, and an article in the docs about DB push in the chat. So that seems to be it. And we can move on to the next lesson. So let's go ahead and do that, lesson 2. The goal of this lesson is to get comfortable with the Prisma Client API and explore some of the available data queries that you can send with it. We'll get to know CRUD queries, relation queries, filtering and pagination, and also introduce another migration with another model so that we actually have 2 models that have a relation in between them. And a couple of hints again for you to get the most out of this workshop, that in cases where you can figure out the right query and you need to take a peek at the solution, I still would recommend you to type the solution yourself, even if you expand the solution block. It's just like a little bit more instructive, I think, and it gives you a better feeling for the API. You can use the auto completion. So I think like typing yourself is always a better way to learn than copying and pasting. I would encourage you to make use of the auto completion. In fact, I'm going to use it myself when I'm showing you the tasks. And then if you want to validate the results of your Prisma Client queries, then you can go ahead and visualize the data in Prisma Studio. All right, let's move on to the first task, and I'll show you how this works. Again, it's the host walkthrough now, so I would recommend you to just pay attention, and then afterwards you get time to work on these queries yourself. All right, to warm yourself up, let's write a query where we just retrieve all user records from the database and then print them to console log. So I'm going back into my VS Code and open the main script file here. And I'm going to start writing my first query. I'm storing the data inside of a variable called result. And I'm using await because Prisma always returns promises for its queries. And here again, we already see like some of the niceties of using Prisma Client. The autocomplete shows me exactly what kind of operations I can invoke at this point in time. And here we have all these top level operations that are prefixed with a $sign. That's actually not what I'm interested in right now, but I'm interested in this property that represents my user model. And if I choose that, and again, just use the dot notation, then I see all the different queries then I can, which I can now send to read and write data for the user table in the underlying database. And the query to retrieve all user record is called find many. And if I don't provide any arguments here, no filters, no pagination, it's indeed going to just return all the records from the database. And in the next step, I'm logging the results. And if I now run this using the npm run dev command in my terminal here, which takes a second to load apparently. There we go. If I run npm run dev, that's the way how I run this script file, then I expect to see the 3 database records returned that I previously inserted using Prisma Studio. So that seems to have worked. That's nice. So let's take a look at the next task, and that's to create a new user record. And the task is to create one that only has an email, but not a name. We recall the name is optional in the database, so we don't have to provide that. I'm again using Prisma's auto-completion here to figure out the right query, and there is a query that's called create. So that looks like what I need. And inside of create, so here it takes an object, and if I want to know what fields I need to provide in that object, I can again hit Control Space, and I see that there are 2 fields that I can provide. One of them is required, so the data field here I have to provide. It's another object, and if I hit Control Space inside that object, I can see that I have 3 fields again that I can provide. One of them is required, the other 2 are optional. ID is optional because that's actually auto-generated. It has a default value in the schema, so that don't have to provide it here. And name is also optional because it's optional in the schema itself. So I have to provide the email, and I'm using the email that has been specified in the task. And if I run this again, we see that it's executed and we get this new database record. If I were to open this in Prisma Studio, this would now also show up there as the 4th record in the user table. And now we already have a task to update this user and actually add the name to it. So let's go ahead and try that, just working our way through the CRUD operations here. So we're at update. Let's see, there is a query that seems like it would do what I want here. Again, it takes an object, and inside that object with Control Space, I see that there are 2 required fields. One is where, that's used to identify which object I want to update by any unique identifier. And in this case, I want to update it by the email that I just provided. I could also choose the ID, it's 4, but I go with email here. And then the second that's also required is the data object. And here I can provide the fields that I want to update, and I just want to update the name. So if I run this again, I expect that I get the same output, except that this will say Alice. All right, everything works as expected. That sounds great. So let's move on to the next task, and that's to add a post table to the database. So we are supposed to, again, run another migration, creating a post model with an ID, with a title that should be required, with content that should be optional, with a published field that indicates whether a post is published or not. So it has 2 states. It should also be required, and by default, any post should be not published. And then we want to configure a relation between the user and the post with these author fields here. So you can watch me do that now. I'm going back into VS Code. I'm opening the Prisma schema file. And I'm copying this just to get the boilerplate for the ID. I call this post and start to write the fields that were specified in the task. So first there was a title that's required, some content that's also that's optional, a published field that has 2 states. So I'm going to model that as a Boolean here. It's required, but it's supposed to have a default value of false. And now we get to the interesting part, and that's the relationship between user and post. And like, who of you here is familiar with modeling relationships in relational databases, and specifically with the concept of a foreign key? Who has heard of foreign keys before? All right, the foreign key is not entirely abstracted away in the Prisma schema. You still have to define it when you're using Prisma. And in this case, here I want to call it the like the author ID, and it's of type int. It has to be of type int because it needs to map to the primary key of the table that I want to relate it to. So this author ID, like when I create a new post record, this field will indicate to which user the post belongs. But that's not all I need to do in order to configure this relation here. But I can also add these relation fields now that are a specific concept to Prisma. And in this case, I want to create a relation field called author that's of type user, because it should point to the user model. And then on the other side, I want to have the posts field, and that's an array of posts. So that's how I can configure the relation inside of my Prisma schema. But at the moment, the Prisma VS Code extension still complains, because I also have to specify how this relation field is going to work. Specifically, what is the foreign key and what is the field on the related model that this foreign key should map to. And I can do that using the relation attribute, where I specify the fields and the references. And the fields are the field on my own model that represents the foreign key. In this case, it's only a single column, but this would also work with multiple columns. If I have a foreign key that's composed of multiple columns, that's also possible. In this case, we only have a single one, and it references the ID field in the user model. So I'm taking that from here, and now Prisma is happy. I can format, and everything looks good in my Prisma schema. Any questions about this? No, that's great. So then I can move on to run the migration for this, npx Prisma migrate dev. And this time I'm going to choose the name add post, because I'm adding the post model. Let's see what's happening on the file system. We get a new migration. If we look into it, we see that it creates this post table that we've been specifying. And it also uses the author ID as the foreign key here, and also references the ID field on the user. So everything as we expect. All right, with that, I think we can move on to the next task, and that's to create a post record with the title Hello World, not yet with an author. So let's just go ahead, use our Prisma Client instance and the auto completion. And so like here's another point of convenience when using Prisma. I just ran the Prisma migrate dev command. So I changed the structure in my database schema, but the Prisma migrate dev command, as I mentioned before, also runs Prisma generate. So my Prisma client is already generated. It knows about the new type that I introduced in my model and exposes new queries for that new type that is called post. So prisma.post now actually gives me all the queries that I saw for user before, also for the post model. And I can go ahead and follow the auto completion to create my first post. What is it? I think I made a small mistake in the Prisma schema. I wanted to make the author optional. And I can just quickly do that with another migration. And now the TypeScript compiler should be happy. Previously, it required me to provide an author ID because that was required and I didn't provide it here. But now I fixed that. The author is now optional, and TypeScript is happy when I just create a post without an author. So I run npm run dev, and I expect my post to be printed here. And as expected, it doesn't have an author yet. Published is set to false, as we specified initially as a default value. No content, only this title here. So let's walk along and see the next task, write a query to connect user and post records. And we actually want to go ahead and configure it via the email field. So we don't directly want to set the ID, but just the email. But like use the email to identify the user who should become the author of this post. We're updating this post. For update, we already know that we have to specify which post should be updated. This time, it's the first post that we created, so it has ID number 1 and the data that we want to update. I'm using the auto completion here to follow because that's going to be nested. We want to update the author. And we don't want to create a new author. We don't want to create a new author. We don't want to delete a user record here. We actually just want to connect this existing post to an existing user record. So I choose connect here, and I want to connect it by the ID. And that's what it looks like. npm run dev. And now we see that the author for this has been set. So this post actually now has been connected with the author. Next task is to write a query to retrieve a single user record. Let's do that. By a unique value. So I'm going to use the find unique method for that. And this takes a where option that allows us to specify a user here. And I'm just using ID number 3. Let's see what user comes out. So that worked. We got to know the find unique query here. And now it gets interesting because we will be talking now about one of the other cool features of Prisma Client, especially when it comes to the type safety that it provides in its queries. In this query, we want to use a find many query, the same one that we used in the first task, and only select a subset of fields. So let's see what this means. If I run find many as before, what do we actually get back? We get back an array of objects that all have 3 fields: ID, name, and email. But what if I don't want to retrieve all of these fields? If I only want to retrieve a subset of these fields, specifically ID and name, but not the email field, what does it look like? I can, again, use the auto-completion this time inside of find many and see that there are a bunch of options that I can provide. And there is this select option here. And this allows me to specify which fields I want to get back from the database. And I want to have ID. So this is what the API looks like, and name. And I specify them here in this object. And when I want to retrieve them, I specify them as true. And let me run this before I talk about the interesting TypeScript aspect of this. Here is npm run dev again. And we now get an array of objects that only have the ID and name as expected. But the cool thing about this particular feature is that if you've used another tool like TypeORM, for example, you know that the properties on your models, they're basically always optional. So at runtime, you don't really have a way of knowing whether a property actually exists or not. And you still have to check for null values because otherwise your application might crash. And with Prisma, that can never happen because if we hover over the result type here, we see that it's not of type user anymore. So if I remove the select, then the result type is just of type like array of users, which has the 3 fields. But if I include select here, then result is statically updated to now only include ID and name is optional in the way that we expect. This means when you're now working with the data that you retrieved here and say you want to access the first user in here, you again get the auto-completion for ID and name, and you're not even able to access the email field. So the TypeScript compiler won't allow you to do this. With TypeORM, this would still be possible, and you could run into runtime errors like this. And also with TypeORM, the auto-completion would show the email field here, but with Prisma, you just can never run into this entire category of errors that you could otherwise potentially run into. So that's a really nice thing about how Prisma can provide strong type safety guarantees. Now let's move on and not only include a subset of fields, but in fact include the include a relation in the result as well. And for that, we're going to go back to the find unique query we were using before. I'm retrieving the user record that has a post associated with it already. And this time we don't want to select a subset of fields. So in here, we could now again say, okay, we only want to have a subset of the fields from this user record. But in fact, I want to have a relation. And that's what I can specify with include. And the API is very similar to what the API for select looked like. So I can choose the relation fields that I specified in my Prisma schema. So posts here, to quickly visualize that. I'm opening it side by side. This post field is called posts because that's what I named the relation field inside of the Prisma schema. So that's why these relation fields in the Prisma schema even exist, to make it more convenient for you to work with these relations inside of your Prisma Client API. And the naming of your relation fields here carries over to the naming of the relation fields inside of the Prisma Client API. Did I change anything? So I include the posts, and this will now include all of the scalar value of this model. So I will get back ID, name, and email. But additionally, I will also get the posts relation back from the database here. npm run dev. And this time we indeed see that we have a nested object with the ID, name, and email, and then this new posts field that has an array of posts that currently has a single post inside of it. And again, if we hover over the results, we see that the type of results has been adjusted. It's now user augmented with an array of posts. So again, it's completely type safe. If I wanted to go, I can go and navigate into the posts. I can grab the first post and still get full auto completion for everything that I retrieve. And in fact, I could go in deeper here. So I can go and nest this even deeper. And at the deeper level of nesting, I can also again use select right here. So inside of include, I can say, but from the posts, I only want to retrieve the ID and the title. And if I run this, then the post that I get back indeed only has these properties. And just as before, if I were to try and access this, then again, I can only access ID and title. So that's really very, very neat to understand about the Prisma Client API and the type safety. I think I just wanted to make another note, but so I'm just going to move on to the next task, and that's to write a nested query to write a new user record with a new post record. So let's go ahead and figure out the first real nested query that we're running. So I want to go ahead and create a new user. So I provide the data as we're used to, and email. Let's Bob this time. And for the nested part of this query, we are going to use the posts field again, the relation field. And inside here, we can now specify, do we want to connect to an existing post as we've done before? That's not what we want to do this time, but we want to create a new post along with this user. And the title of that is going to be I am Bob. And if I run this, and in fact, to demonstrate this, it's not part of the task, but just to make you aware, if I run the code like this, what do you expect to be printed to a console? Two options. Would you expect a flat user object, or would you expect a nested user object that has a posts array? Who expects the flat user object? And who expects the nested user object with a posts array? Okay, and a lot of people just can't decide. That's fair. The second one, the nested one, is actually false. If I run it just like this, let me do it for demonstration purposes, it's just going to return the scalar values again of the user record. And that's because really all the Prisma Client queries that you're going to use, all the CRUD operations, create, read, update, delete, upsert, they will always return all the scalar values of a model. If you want to include a relation in any of these, you always have to be specific, and you always have to say include. So that's why all of these, even the create, update, and upsert queries, always give you the option to include relations here as well. So here is how you can include the post as well. If I run the query like this, we're actually going to run into an error because I already have a user with the email Bob. So let's create Bob2 here, and I am Bob2 to distinguish. But if I run this now and I use include inside of my create query, then I actually get a nested query, a nested result back. All right. Yeah, question.
Maybe a related question, because this is about scalar operations.
Mm-hmm.
In the beginning, when you query, when you wanted to update a single value,
Mm-hmm. Mm-hmm.
how would you do the vectorize? So let's say you want to update an array of items.
Mm-hmm.
Could you then have an array and map each entry to an array?
I think there should be an update many method which you can use for that. So we have some of these batch operations inside of Prisma Client, delete many and update many. We actually don't have a create many at the moment, but that's a feature request that has a lot of thumbs up already. So it's going to come eventually. But yeah, if you have multiple records that should be updated, you can do that with update menu.
I think he was talking about an array of scalars, and then you can want specifically if it's an array of scalars.
Okay, so basically I have an array of post IDs, and I want to assign all of these post IDs at once to the same user.
It would also be a use case, but the first use case was like you want to update like a single property.
Oh, yeah.
Let's say you want to use for 3 users. Yeah. And then if you have like an array of 3 user whatever properties and you iterate, like
would that not be feasible with update menu? Like if you have 3 user records?
Like
okay.
But that's another use case which is also very
okay. Because I thought you were talking about specific an array of scalars. Like that is a relation.
You mean like an array of, okay. So actually, that's an interesting question. You can, inside of your Prisma schema, you can define scalar arrays as well. But actually, I'm not 100% sure. Let me just test this here. I think in SQLite, it's actually not supported because one note about the Prisma schema also is that we're not really trying to add any functionality to the underlying database that doesn't exist in the database itself. We rather want to make sure that you can use the actual features that your database has also in the Prisma schema, but we are not going out of our way to really make sure that you have all the features that you can possibly think of for every database, because that's why you pick a database in the first place, because it has its own strengths and weaknesses. So in SQLite, you cannot do this. But if you were to use Postgres here, then you can define these scalar arrays as well. And there is a dedicated API how you can then, if you have a scalar array and you just want to like add this to this array here, there is a dedicated API for that indeed. Yeah. Let's make sure that we are back to our initial state. Yeah. All right. I think that's it for what I wanted to show you. The last features, the last tasks you can figure out for yourselves. Let me quickly go through the chat here and see what kind of questions have been asked. I didn't see one question, by the way, previously from Conrad. And that was the Prisma schema file can get quite large when you have a lot of tables and columns. Is it possible to have multiple Prisma schema files to split some functional parts of a single application? I'll answer this by opening up a GitHub issue. So you can already anticipate the answer. No, it's not yet supported natively. You cannot split the Prisma schema files into smaller components and then merge them. But there is an open GitHub issue with a lot of thumbs up. So if you're interested in that feature, then go ahead and add your thumbs up to this. But there are a lot of workarounds already by our community. In fact, if you go to like one of the more recent comments here, you already see a list of tools that do exactly this. One that I can recommend is this one, Prisma Aurora. It's actually built by one of our community members who now also is a developer advocate at Prisma. He's called Sabin. And another one that was just published this morning, that's called Prismerge, that actually has another interesting feature, and that's mix-ins. What the Prisma schema also at the moment is not supporting is any kind of inheritance or union types or anything like this. But you can get similar functionality with this concept of mix-ins here, where you can define a number of fields that should be present on all of your models. And then whenever you merge all the small Prisma schemas into a big one, that's when these mix-ins also will be applied. So it's not supported natively, but if you really, really want it, then I think there are enough options for you out there that you can use. All right, that was this question. Let me scroll further to the next ones. So relation schemas are not included by default when running find many. That was a question, but I think I answered it already. No, they're not. If you want to retrieve a relation from the database, you always have to use include explicitly, yes. Next question. Is Prisma support locking the database like SQL select for update statement? Sometimes we need to have exclusive access to modify specific rows in the table to have correct data and disallow other servers connection to change anything here. I think what this question is coming down to is transactions. And if you can lock some parts of the database as long as another operation is going on. And yes, Prisma does support transactions in a variety of ways, actually. So you remember the nested query that you just wrote, where you created a user along with a post that was executed in a transaction. So at the end of that, you would either have both the user and the post created or none of them. And then if you need more flexibility inside of your transaction, there actually also is an API that's called interactive transactions that you can use to like really perform like computations along the way and decide if you want to commit or roll back at any point. Is there any way we can see the transpile from Prisma object to raw SQL? Yes, you can see the queries that are generated by Prisma Client by using the constructor of Prisma Client, specifying the log option, and then you can say what you want to have logged. And there is a special option for query. So if you turn this on, then you will see all the SQL queries that are being created when you run a Prisma query. What happens when creating a new post and in the author ID field, you enter an integer like 1 instead of using connect? Would that mean that it would not be treated as a foreign key? That is just an alternative way of creating a relation between two posts. So in the task that we went through, we specifically wanted to connect by the email field. And for that, we went through that nested query with the connect option. And then we decided we want to connect by the email. But you could already also on the top level just set the author ID. And that would also work. So it's just an alternative API. Another question, can you set it in the schema to include the relations as default? That's an interesting question. So basically, like, the idea would be to say already in the Prisma schema in some way that all the Prisma client queries, which I send for the post like model, say, would include by default the author, and I wouldn't have to specify include myself every time? The answer is no, that's not possible at the moment, but I do think that there is also already a feature request for this. And if there is none, then you can go ahead and create a new GitHub issue. Oh, and people wanted to have a link of that GitHub issue that I showed. Was it here? Is it something else? Okay, so. I'll drop it in the chat. And if we can share the recording of the webinar, the recordings of all the workshops will be uploaded on our YouTube channel after Prisma Day. Cool. Then I'm done with my host walkthrough. Oh, one more question. Mm-hmm. Mm-hmm. Okay. Yeah, and you can also, it's an interesting point, actually, you can also specify the referential actions for the deletion and update behavior here. So you can say on delete update, or on you can say on delete or on update, and then you can specify the behavior for the underlying database. So your deletes could cascade, or you can have no action. Actually, let's see what kind of options there are. I think should help with auto completion. Yeah, so like these are the different deletion behaviors that you can configure. One more thing popped up in the chat. With Bob's example, we didn't get a nested result back, but was the post created? Yes, it was created. That was what I tried to explain before, that if we create a user and a post in a nested query, but we don't use include, then both will be created, but we only get the user back, because by default, we only get the scalar spec, and whenever we want relations, we need to use include. All right, I think I covered all the questions. So now you finally have time to work on these tasks yourself. Okay. Now I'm not muted anymore, I think. And also, sorry to everybody who joined remotely that everything that I dropped in the chat before, I only sent to hosts and panelists. So it was only us here who could see this, but not everybody who asked the questions in the first place. So I dropped some info in the chat in the meanwhile, and that should now be viewable by everybody. All right. I have two more lessons prepared. One about how Prisma looks in a GraphQL API and one in a REST API. And in fact, these two lessons are pretty much equivalent, because in both lessons, it's your tasks to implement API operations, and the API operations, they are identical, except that here it's with a REST API and there it's with a GraphQL API, but the Prisma client queries that you need for both are identical. So in terms of like learning more about Prisma Client, there will be like virtually no difference. What's the preference here in the room? Who prefers to see the Prisma in the context of a REST API? Who prefers to see it in a GraphQL API? Democratically, that's the majority here in the room, at least. Some chat messages also. Well, to be fair, there is a workshop that specifically talks about the REST API in detail later today. So I think maybe it's a little bit more fair to say, okay, we'll cover GraphQL here. And then for those of you who really want to learn about REST, there actually is a dedicated workshop that you can learn, that you can join later today. So let's go ahead with the Apollo server example that I've prepared. One question that I'll pick up later, I think. Okay, so let's move on to lesson 4. In this lesson, we have a couple of additional setup instructions because we're now actually going to work in a different branch. So we're going to stash everything that we have been doing so far. just get rid of it basically, then change the branch and remove the migrations folder and the database, and then also go ahead and wipe our package JSON and reinstalling all the dependencies. And that's it for the setup. So let me go ahead and open this again in Visual Studio Code. Let's walk through the project real quick in the same way that we did before. So starting with package JSON, here is what it looks like. Dependency-wise, it looks pretty similar to what we had before in this plain script project. We have the Prisma CLI and some TypeScript dependencies. Then, because here we're using TypeScript and work with GraphQL, we additionally include the types here. And then as runtime dependencies, again, we have Prisma Client. We use Apollo server in this example. And then we have GraphQL and GraphQL scalars, which are required by Apollo server as well. Quick question again for those of you who have experience with GraphQL so far on the server side. Do you have experience with the schema first or SDL first approach of constructing your schema? Like when I say schema first or SDL first, do you know what that means? Yeah, a few people. And have you heard of the code first approach as well? Code first as well. So when you build a GraphQL schema on the server side, you have these two different approaches. One is to use the SDL first, and one is the code first approach. The difference is as follows. Let's actually take a look because we can make it very tangible just here in this project. This project, it consists, by the way, again, like mainly of this index.ts file. For utility, I also have this short context file to define the type of the context we're using. But really, all the relevant stuff happens in this index.ts file, so no additional kind of layers of indirection, very simple setup. The difference between code first and SDL first is that with the SDL first approach, that's what we're using here. And with an SDL first approach, you're defining your GraphQL schema as a string. And in here, I actually do that in the same file. You could potentially also do it in a dedicated file that is then has the .graphql file extension. But in this case, I'm defining everything in the same file. And then you define the schema and the logic for the schema, the so-called resolvers, separately. But what's important when you define the resolvers is that you follow the structure of your GraphQL schema as well. So notice how here we have this query field inside of resolvers, and then we have all users, post by ID, and feed. And also notice the casing, because the casing is actually relevant. The casing has to map one-to-one to the casing of the operations that I'm specifying here in the schema. And then what I do, I take these type definitions and the resolvers, and I pass both of them into Apollo server. And then Apollo server is going to mesh them together, and it's going to map every resolver to a GraphQL operation that's defined in the schema. And that's called the SDL first or schema first approach in GraphQL. There is an alternative that's called the code first approach, and there are several libraries that enable this. The four ones I can think of are the schema builder when you're using Nest.js, then type GraphQL, which looks very similar to that schema builder in Nest. And then there are two other libraries that are called Nexus and Pothos. And in fact, tomorrow, if you're still around, you'll see a talk from the author of the Pothos library about how Pothos works and how it integrates with Prisma as well. That's the code first approach. And the difference with the code first approach is that you don't specify your schema as a string like this, but rather you just define, like in the case of type GraphQL, you would define your GraphQL types as TypeScript classes, or in the case of Nexus and Pothos, you just get a dedicated like declarative API to specify your GraphQL types inside of your application code. Personally, I actually do prefer the code first approach. And the reason why I'm using SDL first in this workshop is purely because that's the more popular one usually. That's the one that people are more familiar with, and that's the only reason why I'm using it in this workshop. But like personally, I prefer the code first because that also usually works a lot better when using TypeScript. Anyway, that's the quick overview for code first and schema first GraphQL. So now we can move on and actually explore this project a little bit further. So we see that we have all of these empty resolver implementations here. So it's going to be our task to implement them. But the project itself, it's already runnable. And it starts the Apollo server on my local host, port 4000. And once we have that, we can already see that there is some content here. So we can see that the schema has already been picked up, and there has been documentation that's auto-generated based on the schema. And for those of you who've never seen GraphQL, this is a GraphQL playground, and you can imagine it to be somewhat similar to a tool like Postman, for example, where you would be able to test HTTP requests in the context of a REST API in a visual way. And this GraphQL playground enables the same for GraphQL. So inside here, I can now start writing GraphQL queries. And if I send this, then I will get an error back because at the moment we haven't implemented any resolvers. So the goal of this lesson is to go through all of the resolvers and find the right Prisma Client queries to make them work. And I'm going to show you just a few of them. So the all user queries, and this is all also in the Notion document, by the way. Yeah, I should also point out that the Prisma schema itself, it looks very similar to what we used before. The only differences are that we now added these created add and updated add fields and this view count field here as well that counts the views of any post. And of course, I also have to actually run an initial migration again to create the database, generate Prisma Client. And this is also, because it's my first migration, it's also running a seed script that you can also find here in the Prisma directory, where I just define some users and posts already so that we're not starting out with an entirely empty database. So going back to the Notion document here, indeed, we can start with all the tasks, and here's just a list of the tasks and the individual queries that we're supposed to implement. So let's start with the all users query. The way how we can implement these resolvers is to just go directly and return the data. In this case, we are accessing the Prisma Client instance not directly, but via the context object, which is just a good practice if you're using GraphQL and you have things that should be accessed by multiple resolvers, then you can attach that thing to the context object. But here we can use the same auto-completion that we're already familiar with. And I'm using the find many query, just implement this query. So if I restart the server with npm run dev, it's running, I go back into the playground. I now send this query, we actually get the data back of the users. I want to point out one thing at this point, and then you already get time to work on this yourself. Usually one nice thing about GraphQL is that you can have these nested queries, right? Where you can really decide on the front end, okay, what kind of data do I actually want to retrieve from my GraphQL API? But if I send this, even though in the seeding script, I did create posts for all of these users, at the moment, we just return empty arrays for this. And the reason for that is that the relations are not coming entirely for free. And one naive way for implementing this that you already are familiar with would be to use the include option, because here on a top level, we can just say, okay, if we need relations, then I can say, just return me all the posts for this user as well. And if I do this and I restart the server, I would be a happy camper, because if I now send the same query again in the playground, I actually do get the post back. And that's what I wanted, wasn't it? So I can also retrieve additional information from the posts. Who can see a flaw with this approach? Yeah. one of you, sorry, yeah. Exactly. So the problem is that even if I didn't request the relation here in my GraphQL query, and I just send it like this, the Prisma Client query that gets executed for this resolver still does the additional work of retrieving the relation every time that it's executed. And that's, of course, not ideal. And so the way how you solve this in GraphQL is not by resolving relations on the top level, but by leveraging the GraphQL resolver system. And we don't get into details right here, but I just want to make you aware, in case you're ever in the situation of writing your own GraphQL API, that you're doing this with these so-called type resolvers, where you're implementing resolvers for the relation fields yourself. And you can follow a pretty straightforward pattern for this. And that's that you select, again, you use Prisma, you want to return the author for a post. And so you first have to find the post using find unique. And the ID for that post you get from the parent that's passed in here. And then you can use Prisma's Fluent API to get the author of that post. And the reason why I'm talking about a pattern here that you can apply for all of these type resolvers is that you can now basically go ahead and copy this into the other type resolver. And the only thing that you have to do is switch out these two properties. So here we're not talking about the post, but the user. And here we don't request the author, but the posts. The typings line up. We have the best practice implementation for resolving relations in GraphQL. And if I go back to the playground and we go back to include the posts, we actually see that this works. And we also can nest this now as deeply as we want and just ask for the nested data here. And it will come back in the exact same shape that we specify in the query. More questions? Yeah. So you mean in like you mean in the GraphQL playground here? Here. Okay. Right. In fact, this is something that we haven't seen before. You're right. So what I'm using here is Prisma Client's Fluent API, where you can exit or traverse relationships in Prisma Client queries using dot notation. In fact, you could write this. You could write this in a different way as well, where you actually grab the user and you say, I guess, fine. Wait, we want to return the user where somehow it would have to map. Okay, I can't figure it out right now, but like let me think about it and I'll get back to it. That is the Fluent API, where you can traverse the relationship. So at first, like you request a post, and then like on that post, you can request the author for that post as well. And here, the same situation, you request a single user, and then for that user, you request the posts. The difference compared to using include is that here, the result of this actually is, if we look at this, results. I have to make this in a right pen. So the difference to using include is that if you're using the Fluent API, it will be of type post. It'll still be a flat result. But if we were to use include here, then we would have the nested object, right? So the Fluent API really only returns the objects that you specify at the end, whereas include always returns a nested object. All right, there were some messages in the chat, just more GraphQL schema first. One in the Q&A, when I created the relation field for author and post, the user model was automatically updated with a new field post, which is good, but I think that's another question actually that I could also quickly point out. For defining these relations here, Prisma actually helps you if you're not sure how to define a relation between two models, and you're at the point where you know that you want to have a relation from post to user, and you wrote this, and you still get the modeling error here, and you use the formatting now. Prisma is going to fix the error for you, and it's going to create this relation field here, and it's also going to add the relation attribute. In this case, it wasn't smart enough to infer that I wanted to have the foreign key to be named something different than the model. So it's not doing quite what I want. But here as a side note that like Prisma, the VS Code extension also helps you with the data modeling of relations and will insert the missing parts automatically. So this was answered. And last question, in case a user wants to fetch a collection of posts without authors, then there will be a huge amount of SQL statements. Is there any way to include relations on the root level? Only those which come in args? Collection of posts with authors. Isn't that a use case for include? Or am I missing something? Okay. Well, then I consider this question clarified now as well. And you have 5 minutes left to work on this yourself. Oh yeah, another question. Yes. Yes. So the question is that, so assuming I have this query in GraphQL, and in GraphQL, I only specify the ID right here, and I only want the ID, there is still a flaw, right? Because we know that all Prisma Client queries by default return all the field values for a model. So we're indeed still retrieving the name and the email here, even though on the API layer, we only requested the ID. That is true, but it's also not really a concern. To retrieve single scalar values from the database rarely actually accounts for an actual performance bottleneck in your application. And if that at any point becomes the case, then there are ways to optimize this, because what you can do inside here, inside of these resolvers, you actually also get a fourth argument that's called the info argument. And that carries the information about which fields have been requested in the GraphQL query. So you can read the information from that info argument, and based on that, you can construct the object that you're then passing here into the select option to only really retrieve the fields that you want to retrieve that are requested in the GraphQL query. And in fact, there is a community project that does exactly this. That's called Prisma Select, and that solves exactly that problem in these cases. It takes the info object, it creates the select option here, and then you can simply pass it into your queries, and that's how you make sure that you only request the fields that have been requested in the GraphQL query itself. But good point. All right, 3 minutes left, but you can contact me afterwards. I'll stick around anyways. If you have any follow-up questions, you can take this entire workshop document at home with you to continue working on that. And yeah, it was a great pleasure to have you here today. And I'm excited to see you for the rest of the day and tomorrow. Thank you.